Have you ever stopped to think about the tiny microchips that power the electronic devices we use every day? From smartphones to computers, microchips are at the heart of the technological revolution that has changed the way we live and work. But have you ever wondered how they are made? In this video, we'll take you on a fascinating journey through the microchip manufacturing process, exploring the intricate steps involved in creating these tiny marvels of engineering. Join us as we go inside the microchip factory and uncover the secrets of how they're made. Microchip manufacturing is a complex process that involves several stages and intricate techniques. At its most basic level, a microchip is a tiny device that contains transistors, resistors, and capacitors, all of which are designed to perform specific functions. These components are arranged in a specific pattern, which is created using a process called lithography. Lithography involves using a mask to transfer the pattern of the microchip design onto a silicon wafer. The wafer is then coated with a light-sensitive material called a photoresist, which is exposed to ultraviolet light. This process creates a pattern on the photoresist, which is then etched into the silicon using chemicals. Once the pattern has been etched, the microchip undergoes a process called doping, which involves adding impurities to the silicon to create regions that are either positively or negatively charged. This process allows the microchip to conduct electricity and perform specific functions. The next stage in the process is to create the metal interconnects that connect the various components of the microchip. This is achieved by depositing a thin layer of metal, typically aluminum or copper, onto the surface of the microchip using a process called sputtering. Finally, the microchip undergoes a process called packaging, which involves enclosing it in a protective casing and attaching it to a lead frame. This allows the microchip to be connected to other electronic components and integrated into electronic devices. Microchip factories are highly specialized facilities that are designed to produce the tiny microchips that power our electronic devices. These factories are highly automated, with machines and robots performing most of the manufacturing processes. In this section, we'll take you on a virtual tour of a typical microchip factory and show you how microchips are made. Clean room. The first thing you'll notice when you enter a microchip factory is the clean room. A clean room is a highly controlled environment that is designed to minimize the amount of dust and other particles in the air. This is because even a single particle can cause a defect in a microchip, which can render it useless. To maintain the cleanliness of the clean room, workers wear special clothing, including gowns, gloves, and masks, and the air is filtered and recirculated continuously. Lithography. The first stage in the manufacturing process is lithography, which we discussed in the previous section. In the lithography room, a large machine called a photolithography system is used to transfer the microchip design onto a silicon wafer. The photolithography system is controlled by a computer, which ensures that the pattern is transferred accurately and precisely. Etching. Once the pattern has been transferred onto the wafer, it undergoes a process called etching. Etching involves removing the parts of the silicon wafer that are not part of the microchip design. This is achieved by applying a chemical that reacts with the exposed parts of the silicon and dissolves them. This process creates the channels and spaces that will later be filled with the metal interconnects. Doping. The next stage in the process is doping, which we also discussed in the previous section. Doping involves adding impurities to the silicon to create regions that are either positively or negatively charged. This process allows the microchip to conduct electricity and perform specific functions. Deposition. Once the doping process is complete, the microchip undergoes a process called deposition. Deposition involves depositing a thin layer of metal, typically aluminum or copper, onto the surface of the microchip. This process is achieved using a technique called sputtering, which involves bombarding the metal with ions to create a plasma, which is then directed towards the surface of the microchip. Etching. Again. After the metal has been deposited onto the microchip, it undergoes another round of etching. This process involves removing the parts of the metal layer that are not part of the interconnect pattern. This creates the channels and spaces that will later be filled with more metal interconnects. Planarization. The next stage in the process is planarization, which involves smoothing out the surface of the microchip to create a flat, even surface. This process is achieved using a chemical mechanical polishing (CMP) machine, which uses a combination of chemicals and mechanical abrasion to remove any roughness or unevenness from the surface of the microchip. Packaging. Once the microchip has undergone all of the necessary processes, it is ready to be packaged. Packaging involves enclosing the microchip in a protective casing and attaching it to a lead frame. This allows the microchip to be connected to other electronic components and integrated into electronic devices. The packaging process is highly automated, with machines and robots performing most of the work. Testing. Before the microchip leaves the factory, it undergoes a series of tests to ensure that it functions properly. These tests are performed using specialized equipment that can detect even the smallest defects or flaws in the microchip. If a defect is detected, the microchip is discarded, and the process starts over again. Quality control and testing are critical stages in the microchip manufacturing process. As we mentioned in the previous section, microchips undergo a series of tests before they leave the factory to ensure that they function properly. These tests include visual inspections to check for any physical defects or irregularities, electrical tests to ensure that the microchip performs as expected, and functional tests to ensure that the microchip performs its intended function. The tests are performed using specialized equipment that can detect even the smallest defects or flaws in the microchip. Quality control is also an ongoing process throughout the entire manufacturing process. Workers must adhere to strict protocols and procedures to ensure that the microchips are manufactured to the highest standards. Any deviations from these standards can result in defects or flaws in the microchips, which can compromise their performance and reliability. Overall, quality control and testing are critical stages in the microchip manufacturing process. Without these processes, we would not have the reliable and high-performing microchips that power our electronic devices. Microchips have a wide range of applications in our daily lives. They are found in nearly every electronic device, from smartphones and computers to TVs and home appliances. Microchips are also used in the automotive industry, where they help to control engine functions and improve fuel efficiency. In addition, microchips are used in healthcare, where they are used in medical devices and diagnostic equipment. One of the most significant applications of microchips is in the field of artificial intelligence, AI. Microchips are used to power AI algorithms and machine learning models, which are used in a variety of industries, including finance, healthcare, and transportation. AI is driving innovation and change in many industries, and microchips are at the heart of this revolution. Another exciting application of microchips is in the field of nanotechnology. Scientists are exploring ways to use microchips to create tiny machines and robots that can be used to perform tasks at the molecular level. This could lead to new breakthroughs in areas such as medicine, where these tiny machines could be used to deliver drugs directly to cancer cells, for example. Overall, microchips are changing the world in countless ways, and their applications are only limited by our imagination. From powering the electronic devices we use every day, to driving innovation in fields such as AI and nanotechnology, microchips are an essential part of our lives and will continue to shape the world we live in for many years to come. The manufacturing process for microchips is a complex and intricate process that involves precision and attention to detail at every stage. From the clean room to the packaging stage, every step must be performed with care to ensure that the microchips are of the highest quality and reliability. Quality control and testing are also critical components of the process, ensuring that the microchips function correctly before leaving the factory. The applications of microchips are vast and continue to evolve, from powering our electronic devices to driving innovation in fields such as AI and nanotechnology. We rely on microchips in almost every aspect of our lives, and their importance will only continue to grow in the years to come. We hope that this video has provided you with a better understanding of how microchips are made and their significance in our daily lives. If you have any questions or comments, please feel free to share them below. Thank you for watching, and we'll see you in the next video.